Hi students, let's take up a question. Find the accelerations A1, A2 and A3 of the three blocks shown in the figure. If a horizontal force of 10 Newton is applied on A 2 kg block, B 3 kg block, C 7 kg block, and we are given G is equal to 10 meter per second square. First of all, let us find out the maximum value of static frictional forces acting between the blocks. Between 2 kg and 3 kg block, let's call it F1 maximum. This will be equal to mu into N. Mu is 0.2 and normal force is 2 into G, so this is equal to 4 Newton. Between 3 kg block and 7 kg block, let's call it F2 maximum. Mu in this case is 0.3 and normal force is 5 into G, so this is equal to 15 Newton. Now let us take the first case. In this case, the 10 Newton horizontal force is applied on 2 kg block. Let's make free body diagram of 2 kg block. 10 Newton force in the forward direction, static frictional force F1 in the backward direction. Let us take its maximum value, 4 Newton, and since external force is greater than maximum value of static frictional force F1, so there would be relative motion between 2 kg and 3 kg block. Let's find out the acceleration of 2 kg block. The net force is 10 minus 4, mass is 2 kg and acceleration is A1. So this gives us A1 equal to 3 meter per second square. Now let us take 3 kg mass. Frictional forces act in pair. So this force of 4 Newton which was acting on 2 kg block in the backward direction will act on 3 kg block in the forward direction. Static frictional force F2 will act in the backward direction. Maximum value of F2 is 15 Newton. Since maximum value of static friction F2 is greater than 4 Newton, so there will not be any relative motion between 3 kg and 7 kg block, and they are going to move together. Let's find out their common acceleration. Net force is 4 Newton, mass is 3 plus 7 into A, so this gives us A equal to 0.4 meter per second square. So A2 is equal to A3 and this is 0.4 meter per second square. Now let us take second case. In this case, 10 Newton force is applied on 3 kg mass on 3 kg block in the horizontal direction. Let us make free body diagram of the blocks. 3 kg block, 10 Newton force is acting in the forward direction. static frictional force from 2 kg block F1, static frictional force from 7 kg block F2, and since upper block of 2 kg has a tendency to slip in the backward direction, so static friction will act on it in the forward direction. Similarly, 7 kg block will have tendency to slip in the backward direction, so static friction will act on it in the forward direction, F2. Now let us assume all three blocks are moving together. So let us find out their common acceleration. The net force is 10 Newton and total mass is 2 plus 3 plus 7 into A. So this gives us A equal to 10 upon 12, and this is equal to 0.833 meter per second square. So this is the common acceleration. And now let us find out the friction force required by 2 kg block for this acceleration. So 2 kg block will require a friction force of m into A, and this is 2 into 0.8. This is equal to 1.67. So 2 kg block will require a friction force of 1.67 Newton. And since available static friction force of 4 Newton is greater than this 1.67 Newton, so there will not be any relative motion between 2 kg and 3 kg block. So now let us find out the friction force which 7 kg block will require for having this acceleration A equal to 0.833 meter per second square. So this will be equal to m into A. M is 7 and acceleration is 0.833. So this is 5.8 Newton. And since available static friction force is 15 Newton, which is greater than this required friction force, so there will not be any relative motion between 3 kg and 7 kg block. So therefore accelerations of 3 blocks would be equal. A1 equal to A2 equal to A3, and this is 0.833 meter per second square. Now let us take up the third case. In this case, the horizontal force of 10 Newton is applied on 7 kg block. Now we are aware that the maximum static friction force between 3 kg and 7 kg block is 15 Newton. And since maximum static friction force is greater than this external force 10 Newton, so there will not be any relative motion between 3 kg and 7 kg block. Now let us find out whether there would be relative motion between 2 kg block and 3 kg block. For this, we will have to find out common acceleration, assuming all three blocks move together, and this we have already found out equal to 0.833 meter per second square. Now let us find out the friction force required by 2 kg block for this acceleration. this will be equal to m into a. Mass is 2 kg and acceleration is 0.833 and this is 1.67 Newton. And since this friction force is less than the available static friction force F1, or we can say that available static friction force of 4 Newton is greater than this required friction force. So there will not be any relative motion between 2 kg block and 3 kg block. So all three blocks will move together. Therefore, A1 will be equal to A2 and this will be equal to A3. And this is 0.833 meter per second square. Alright, thank you very much.